Good morning, everybody. I hope you're well. A huge thank you for everyone who's been supporting us and the videos that we've been releasing on Eigen TV. Today's conversation is very exciting because we have both Dave and Andrew from KBR with us. And today's conversation is going to be around digital twins. So this is actually a really interesting conversation. I've been privy to some offline conversations around this, so I'm excited to get started. So I think what we're going to do today is probably just kick off with the question about what is a digital twin and let the conversation lead us. So I'll hand that over to you, gentlemen.
So I'll start. I really think that a digital twin is a faithful and accurate representation of the content and the components of the real life physical sister twin that is out there in the field. The question is, how do we build one? How do we make it trustworthy? And how do we make sure it's right? I'm sure there are other views, and I'm sure these guys will chip in with their thoughts.
Yeah, thanks, Dave. So I guess that's a key question, certainly I've had, is what does it look like? How do you get your hands on it? How would you interact with it? And one of the things that I guess we both shared over the years is it isn't actually one system. So that is probably important to say that from early on, that we're not talking here about a single digital system that rules them all. that we're actually talking about a collection of things. And Andrew, you make the point that actually it really needs to start in the project. That this is, if you're doing a project, then the value that it can provide, but also just its existence has to start in the project. So just share with us your dream for what that.
Thanks, Murray. Yeah, well, the digital twin it's a very, I find it an extremely exciting tool that we've got here. And if I can picture myself as I go onto a project, and I've run a lot of large projects, if I could picture myself standing at the point that project actually starts up, that's actually the point where the project turns into operations. But if you then wind back to the start of the design, and you could take all that information and that knowledge and that intelligent live model back to the start and put that into the design process, that's really what we're talking about here. So to me, it's starting with the end in mind, getting a good blueprint on the understanding of what operations need, and bringing it back into the start of when you're actually designing, so that through that process, it all heads towards that end objective.
You use airports as a really good analogy when you were talking around digital twin. I just wonder, for anybody who's listening to this at the moment, whether that's something that we could talk about just to help plant and cement all of the different things that we've been talking about.
Yeah, great call, because we had a really good discussion about that, actually, about the idea of airports. Every airport itself is different, but within it, it has different systems and they do different things. But there's an information handover that has to happen, particularly around the plane, because a plane will be refueled, get a schedule, be handed over to air traffic control when it takes off, and then be handed across air traffic controls until it then lands at another airport. The actual implementation of those systems will be different in different countries, but the end result the information has to successfully transfer the passenger lists, everything.
And so physically, the nozzle that connects the bunkering machine to the airplane needs to be the same, irrespective of where it is in the world. So you can't have a sort of Russian standard for connecting your hose to your fuel tank. You have to have a universal standard. So that's a typical case where we need to agree on a standard on this, guys. It doesn't matter if the truck providing the fuel is a Ford or a Vauxhall, but it has to have that connection point on it.
Yeah.
On the end of its hose.
I think airports are great examples because they're high turnover. Well, not in the current COVID, but normally high turnover. Of course, everything from the fuel nozzle to the way you get on and off the plane to the spare parts, everything's interchangeable. I think it's a great example. And that's no doubt, I think, where we're heading with our industry and the big energy product companies and energy projects is interchangeability like that. It's a really good example.
Yeah, and again, you've got different systems. The baggage handling system, they have to come together at some point, because this passenger is on this plane. Yes, but maybe we could learn a lot.
Safety
Good thinking.
Safety governs like it does in our industry.
Traceability, certainly the part, yes, replacement of parts. Very true. A lot of real-time data as well comes off an airport. So how do you deal with the idea, this information maturity model that you have to deal with every day in the project life? Because you start off very early and you've got a concept, and that concept is changing really fast, because someone will go, oh, I think we should do it this way. And then you'll look into it and go, oh, no, we shouldn't, because that's really expensive, or it's just not going to work. Let's do this instead. And so you've got a rapid changeover. And if you had to build an entire digital twin and then collapse it, that would be way too expensive. That'd be prohibitive. So how do you envisage managing the uncertainty levels that you have to deal with already?
Yeah, I think the key to that, Murray, you said the different stages. So at the concept and the pre-feed stages of the job, it's all about being very agile and this rapid concept, looking at things from the economic point of view, the safety, and that screening. So at that point of the job, I'm not suggesting that there's going to be a complex model built of all of that. That's actually up front to get to a basic concept. I guess for me, once that's then locked in, and the job's actually going to move into a front-end definition and then beyond. Actually, from that point on a single concept, a selected concept, can really start to build up the model from a 3D point of view, from a process and design point of view, an environmental point of view. So I guess I'm separating the two out there, Murray. Agile in the concept point, and then really getting into this, building this model if a little bit more into the feed stage.
Yeah, this is sort of building up on that, but really one of the things that the digital twin also has is a memory of what it was. I'm a firm advocate of starting the digital twin very small, as Andrew described, and developing it as it goes through the project life cycle and then on into operations. One of the things that also means is you get a memory of what the concepts you evaluated and rejected, the ideas you had, the decisions that you took along the way, in a timeline alongside the shape of the product it is at any one time, which means that you can go back to, well, why did we look at that concept, and what did we come up with, and why are we looking at this concept again? We ruled it out 5 years ago. It's not going to work. So that kind of helps us to be more efficient, but it also lets, if there's an incident and something has happened, it enables us to look back over that project memory very easily to see really where the decision was taken. Hopefully not so that we can point the finger of blame, but so that we can actually get the facts about why that incident took place, what the precautions we put in place or maybe didn't put in place to try and deal with that incident. I think that's a key point, really. And I think one of the things I'm seeing now is the real need for that project memory.
Wow, so that's a huge thing. That's a whole section of a digital twin that actually is really talked about. Because what you're talking about there is the reason for being. And another step is reason for not being.
Yes.
Okay, it's this, but why was it not that?
Yeah.
And
could it be just as you're going through that life cycle and that memory, if you say, well, okay, we discarded it 5 years ago, is it possible that it just wasn't right for that time, and actually you can then use that to say, well, now is, and alter that rather than just discard it, reconsider it? Is that something that's possible?
Yes. I'm just trying to think how that might work. Really what we're trying to do is we're progressively refining the design, and yes, it may well be that the idea we had 5 years ago just was an idea whose time hadn't come, but that gives us the opportunity to see, well, why did we rule out that decision, and what's changed that enables us to make that decision, change that decision now. Remembering also that there's 5 years of elapsed and the whole thing might have changed in that intervening time. The other thing that's really quite important is not only do we record every component that makes up the digital twin, the technical aspects of all the equipment items, the decision record, the schedule, and the status of things, but also we need to know which bits of it, especially during a project, are immature in the design process and which bits aren't. And that's where we've got this thing called maturity management. So associated with every item inside the digital twin is an understanding of its status in a common and consistent way. So we can say, you know, this pump, it's really, we've placed the purchase order, we've ordered the pump, we really shouldn't change it. Whereas this vessel, maybe they may not have started building it yet. So that's a really powerful thing, especially when it comes to managing change. Gives you the ability to focus on the things where the cost of change is relatively small.
There's two thoughts now come into my mind, and let's put them down here and we'll decide how we get to them. But one is abstract concepts and actually modeling things like a decision. So that's one thing that I want to talk about. And the other thing is then later in the life, how do you make sure that if you search the model, your results are useful so that you don't return every possible variant of an object over its entire life? So, okay, let's take the abstract concept thing. Steve, you've just mentioned the idea that you could go back and visit a decision. So in reality, that's really, really hard. I was just trying to search my emails for an incident that happened in 2013 on an interface we were building when we had a problem with it. And it was quite high profile at the time, and I got called at 3 a.m. But I couldn't find a single document that summarized it, because at the time it was a stream of consciousness happening over telephone calls, text messages, emails. There was an incident report, but I couldn't find a copy of it on my local computer. We'd archived the project. The actual, what was very real at the time as a concept of an incident, actually to go back and visit it, the information that was all spread out and it's very hard to find it. So that means on top of this idea of modeling your tags, your physical objects you want to build, you're going to need a way of modeling the fact that this is a decision. A decision has been taken. We haven't really explored that as a conversation at all, actually.
Yeah.
What are your thoughts on that, Andrew?
It would be extremely useful. It's probably a transformational thing that might be beyond what we've actually used it up to now, but the boundaries of this are moving all the time, Murray. Record the major decisions that are made, and as you say, it can be challenging to unpick them all. The digital twin becomes particularly useful, as I said before, when the job is actually getting into the clear forward path on a set concept going forward. I think that's where I've seen tremendous value come out of it. In terms of a decision record and how you got there, that's a great challenge for the future, isn't it?
I'm going to challenge that, Andrew, with a couple of war stories. Firstly, the railway project I recently worked on absolutely had to have the decision record as part of its digital twin. The reason being was the railway was going to be widened, and and there's a railway running through Wimbledon that's going to need to be widened, by the way. And you're faced with a decision: do I widen the railway on the left-hand side of the railway or the right-hand side of the railway? And in order to do that, you're probably going to knock down somebody's house or somebody's business. The project needed to have absolute good grounding in the technical decision as to which side of the railway they widened it on for all time, because when the time comes to knock down somebody's house, they will raise it in a court of law, and they will go over and examine in minute detail the decision that led to that, the process that led to that decision, because that old lady doesn't want her house knocked down for very good reason. The other one is, I don't know if you remember, but the Manic software, everyone loves to hate, was designed with that absolutely in mind. So generally a decision is associated with something. It might be associated with a certain pump, it might be associated with a system, or it might be associated with an overall facility. We have decided to increase the throughput of a facility from 300 million barrels a day to 400, for example. So that really is you associate the decision, this abstract concept, with something physical. Just like a schedule, the date upon which you're going to install a vessel is associated with that vessel. And that boils down to, the geeky term is the data model. How are we going to connect the abstract decision item, decision object, with the physical object that decision is bothered with? So whilst that's really difficult early on in the project, when you haven't defined your systems, you're still working at facility level. How many facilities, how many platforms are we going to use to develop that field? Is it going to be 3 or is it going to be 4? We can still associate that decision with something. We have to, in order to keep that decision record accurate. I'm not saying it's easy in the early stages. It gets a lot better and a lot simpler as the project matures and the number of objects in the asset grows and grows and grows.
So Dave, are you thinking then that a way to solve this is rather than having to model the decisions alongside the physical tags, you might just have a pointer?
Yes.
So you mentioned a system called Manic.
Yep.
Maybe that's your system of record for decisions, and all you're making then is a pointer between your main model. And so the end result from a user perspective is not some all-knowing system, some oracle that they can just consult. Why did we decide to do that? What it is they still have to follow a breadcrumb trail to some extent, but it's making that process a lot easier for them.
Yes, most certainly.
Okay, so we're not talking here about an all-knowing system. We're talking about making it much more efficient to follow the steps again in the future.
Yeah,
because I think, if you look at where the value is for the client, Murray, if you put a bit of a client perspective on it, where's the value for them? If they've got a model that reflects what they've, an electronic model that reflects what they've got, obviously in the real world, and they can do things like maintenance planning on that, they can do performance planning on that, they can train their people on that. That, to me, if I got the client, that's real money, that's benefits, isn't it? Kind of looking backwards and the paper trail and everything, I'm just testing how useful that is. Although it's important to have built it on the right blocks. I get that from the right foundation. That end use that I'd say.
So that you raise another point then about cost versus value. So cost of building and I guess cost of maintaining. Then so there's some sweet spot once it's in operation. What you're saying is there's a certain level of functionality which is really valuable to them, but beyond that, it's not really valuable, and you could spend a lot of time making something absolutely spot on.
And that's a really good point, because that's where clients, has that point been found? I don't think so. And clients are working out where that point is, the level of detail they're going to put into it, or ask at the likes of ourselves or yourselves to build into it. There's also suppliers as well with all the packages. There's lots of information going in there versus what they're going to get out the back end. And leadership role here to try and acquaint our clients. I got asked a few years ago a very good question from Statoil, now Equinor, and they simply said, when we were talking about these futuristic models, they said, what's the product and what's the benefit and what's the cost of that service to us? And I think that's the key thing. What we've got to do is help a client relate the product that we're giving them with the benefit they get, and link that in fully into the business model.
Yeah, I always do the what's in it for me test. You can, generally it is perceived that you have to spend a lot of money to give the client the all singing, all dancing model that they specify for delivery when they go into operations. My view is that if it doesn't have value for us in the project phase, then they're going to struggle to get it. They're going to struggle with quality, and they're going to struggle with spending the extra money to try and get it. My principle is, if it doesn't add value to us now, it is going to be very hard to do and probably isn't worth doing for us. There are some exceptions to that, but by and large, I've found that if we build a digital model now, a digital twin now on the project we've just been working on, for example, it adds value to the feed stage now by building this little baby digital twin. We wouldn't expand it. We wouldn't do any extra work that requires extra cost. We are simply doing what we've always done, only doing it in a more rigorous manner and centralizing all that information into one place and structuring it very carefully. So the man hours are actually less, because as we're using the data, as we're using the content of the digital twin, we're finding it much easier to find. And the other thing that's really important is we're finding that the information in the digital twin is trustworthy. My view is that trust is the most important word in the whole of this conversation.
So we spent some time talking about what a digital twin is and had some, some brilliant discussion around it. I think it'd be really good to also discuss what a digital twin isn't. So obviously lots of people may have a different view on what they think a digital twin is. And though we've just been talking about that, what in your minds, what isn't it? And I think, that'd be quite interesting to hear your view on that.
It is the data. The digital twin is the data, the content. It isn't the software, although software, lots of software, really, really helps you contextualize, understand, view the data. But the digital twin is the data. You cannot buy an application with a digital twin, for the digital twin. You would probably buy a collection of applications.
Yeah, I definitely agree. I think the picture is like of 2001: A Space Odyssey, and the computer. How is it that you can just ask any question and it'll answer you with whatever? Maybe one day, but it's certainly not now. And I definitely don't think that's a digital twin. I think the reality of a digital twin is a lot more closer to home. And it's a combination of things like a search interface, tools to interact with the different types of data, different applications, certainly. And an example might be Google, for example, that's our way into a lot of stuff now on the internet. But then we go off onto the different websites, depending on what we want to do. And we spend time there, but we have like a map.
The map is the information standards and the data model. So we know that let's go back to that change thing. We know that the change ID and the changes are all carried in a database somewhere, but the change is associated with an item that's somewhere else. The tag number, which is in the central tag database, the 3D space that tag number occupies, etc., etc., etc. So they're all interconnected, but they are not one system.
So I've just add a bit to that. So just to Effie's point, what it isn't. To me, it isn't the oracle. It isn't more accurate than the best information that have gone into it. So that's an important point here. And I think people can see a massive data and think there's lots of knowledge. So I've worked with some extremely useful and interactive digital twins, but they are, again, only as good. Is it being maintained? Is it got the latest information on upgrades, especially when you go into operations? Does it have all the recent work that's been done on that facility? So I suppose it isn't more accurate than checking and talking and communicating with people to check that's a very important. And the other thing I'd say it isn't just a repeat of the 3D model. I think people get a little bit confused here. The 3D model is an integral piece of it, but it's far more than that. It's the overlay of the 3D and the system design, all of the architecture of the project, and again, all the data and knowledge that's gone into it. So I think those are two key things. It's not just a 3D model, and we mustn't fall into the trap of thinking it knows more than the data that's been put into it.
And it isn't perfect, like us, really. That's a good point. So it isn't complete, and it isn't entirely accurate, but we have a way of finding out where the inaccuracies are and improving on them. And also, as time unfolds, we have some ideas about how things might be made more perfect, how you might add extra features, how you might change features, how you might retire features that were useful once, but maybe aren't useful in the future. So that's another feature of it. It's not perfect.
That's really important points that actually we hadn't even discussed up till now, because that really changes how you view it. What we're saying now actually is digital twin is an advisory, I hesitate to say even system, because we're saying it's not one thing. It's an advisory entity that, so to your point, Andrew, the 3D model is a lens that you might view that data through, and it helps you contextualize things much quicker than previously. So it's helping you to interpret and view things in context quickly, but it's not taking the decision for you or telling you what to do directly.
Correct.
Actually, so it's very much an assistance.
I'm slightly uncomfortable with that. I think actually there are things in it that are perfect. Let's take the example of the P&IDs. I hate to use the idea of drawings, but they're still very important. the digital twin will contain the PNIDs in their as-built state during operations. That is the only place we will have them. So they are the system of the store of record for those things. But there are some things that are incomplete inside it, especially during the project. But we know which bits they are. We know from some understanding of their maturity, for example, how imperfect they probably are. So yes, it's advisory, but it does contain the best information we've got about the plant. But there will be areas where it may change because there are imperfections. And we use reporting to try and identify those imperfections. Tell me the bits where the such and such kind of a check hasn't yet been performed so that I can perform that check, is an example of the sort of questions you might ask the digital twin.
And so those questions, one might use a system like Aviva already to do that.
Yeah.
So let's say Aviva Net, you'd already have your PNIDs and you may have your maintenance management in Aviva as well, or SAP. So what we're saying, so those systems wouldn't get replaced. What you're saying is they just become part of the envelope.
Yep.
And by having information standards, they allow the sharing of information across, or such that it can be viewed through a different lens, like say the 3D model or in other tools.
And the systems I call the common data environment, which I've stolen, the term I've stolen from the BIM infrastructure industry, to try and bind the thinking together on this. So the common data environment would contain the tool used to update the maintenance information in the overall digital twin. It's still probably something like SAP or Maximo. It doesn't really matter. And so on and so forth. So, and some of the tools you have simply display information, such as Aviva Net. Some of them are places where you edit the information, such as the PDMS E3D 3D model, where you might, by the way, other 3D modeling tools are available, where you might make the change and then publish to the visualization environment. Okay.
So change, right, that's a really important subject, actually. And it becomes, as soon as you go into production, this becomes one of the key considerations. So let's think about the maintenance end of the digital twin. Because if we're saying it's not one system, we're across multiple systems, you now have a question of consistency of information across those systems. It becomes very expensive to do that manually. So one way you can handle it is to make a change management process, and you rigorously have to go through, you change this system and therefore you then have to change this and this. Do you think should we be developing intelligent tools? And maybe this is a role for AI, maybe not AI, but certainly pattern recognition software, or something that could use the relationships in the data, the digital twin or common data environment, to audit the consistency across those systems, like a process that runs in the background.
Yes, I think we could. That's what we sort of do now on projects. For example, we know that the pipe is defined by the process engineers in a process simulation model, and then it finds its way onto the PNID and eventually into the 3D model as a route. They've all got the same name, and what we need to do is say, well, did the pipe that the process engineer simulated in his HYSYS model, for example, did that get correctly represented in the PNID? Did that then get correctly passed over to the 3D model, where the piper made it into a piece of physical material, and then onwards into the actual build?
But that problem in itself is huge, because in HYSYS, as your process simulation, it's one pipe, and it probably doesn't have the pipe name. It probably has just a 2-digit number in the simulation. And when it gets into the PNID, often it's actually 20 different sections of pipe, because there'll be the straight sections, the corners, the elbows, the T's, the reducers. They're all entered as separate things. And so the idea of the pipe, at the lowest level, it doesn't even exist. All you have is pipe segments.
I think we generally group them all together in the 3D model as the pipe that has its same name as on the PNID.
Right.
And I think when it comes down to the process engineer running the simulation, probably that's true earlier on in the life of the facility, especially when you haven't decided what concept you're settling on. But nevertheless, the pipe name does tend to persevere these days. So you can trace, it may not be the same, but you can trace through the whole chain. And I tend to take the view that the simpler this is, the better for everyone. So I would like it if the process engineer did use the same as the pipe name, or some way of interpreting it and translating it into the one that ended up in the 3D model, as it were.
This knocks onto a good, we haven't used the word perhaps integrated so much in this discussion, but the digital twin is very much integrated. So the PNID, I see the PNID overlaid totally with the 3D model, overlaid with the process design, and ultimately with the operational. So just to the pipe example, if something is changing on that PNID, then it's integrated with a need and a change on the physical, being the pipe or the steel or the support. So that does get worked out through, and the digital twin is great for capturing all that, Murray, and then for communicating it. Because remember, someone's building this as well, and getting that through to the folk that are actually in fabrication, and then that quality check back for the as-built. So I think it covers this very powerfully. I've seen some really good examples of this working.
Yeah. So just talking there, actually, one of the other things that it makes me think is the digital twin isn't cheap. That actually all we've been describing is actually it's work.
But it's adding value over the life of the facility, over the life of the project, and it's going to continue adding value into the operation, even though it's expensive. It's less expensive than the alternative.
I would use the word investment. I think that's the right thing to do. And as I mentioned before, what's the product? What's the benefit? Articulating that as an industry and as individual companies, and most importantly, probably as an integrated solution to the client. What is the product? What's the benefit? What's the cost of the service, and how does it fit? There are huge benefits and outcomes in safety, in cost, in schedule, reliability, predictability, all these things. We have to have the leadership to actually take the client to what those are, is my opinion on this. And there's more to go in that area, would be my observation.
Yeah, okay. And so to the point then about the journey, because Dave, you make an interesting point about the need to evolve towards this. I guess that comes from the reality that you can't just hit the stop button on an operation and switch out to a different way of working at all. It has to go step by step. And so do you see a route from where we are now to a much more integrated digital way of doing it? And just speaking in practical terms, like, actually, we're going to have these systems for initially.
Yeah, I can. I think actually you don't have to change very much initially. What you have to change is the underlying data model. So you don't treat your maintenance management system as an entirely separate thing from your engineering environment, an entirely separate thing from the scheduling environment. Take those three examples. You treat them holistically and you join them together. That's what we've been trying to do on our projects lately, so that you can then say, I need to know when this item is going to be erected. It's really easy because the item has a reference to the activity code that is something to do with the erection sequence in the planning tool. So you can say this is associated with that, and then I can see the dates for putting that object out on site, as an example, right? Yeah. So it's all about using what you've got, only using it in a more value-adding way, so that all this stuff is adequately joined up. So that's one of the key things, really. But that has value when you're planning construction anyway, because you've got to do that work. You've got to say, well, when do I have to start manufacturing of that item in order that it gets out of the factory gates, onto the ship, across to the construction yard, in time for it to be put up on site anyway. So that's happening anyway. There's nothing new about this.
So are you just saying that to do digital twins, the first step is just extending the engineering numbering philosophy early in the project and enforcing it across stuff? Is it really that simple?
Well, that's what I've been doing.
Yeah, it's getting a structured approach and building it in from the start, Murray. I agree with what's been said. Just to go back on the comments of cost, you know, it actually through if you break it down into the engineering, procurement, construction, commissioning, operations, I think you have to. I would say the phases through the engineering, procurement, construction, I think we're doing what we normally do anyway, but it's reinforcing really good sound practice and giving us an integrated product. I don't think there's more cost. That's my personal view. Then client decision when you go into operations, whether you're going to keep this thing updated and live through the operational phase, and that's where the investment comment I made.
Yeah,
that's certainly tremendous benefits.
Yeah, I think that's where I'm coming from with the not cheap. It's that, but there's two aspects. One is you have to be committed to it, and then maintaining it. If you start a project with one, then you have to maintain it through operations. But the other is if you're retrofitting one, if you're coming in to do this from scratch, to sort of caricature the process that it normally goes through, I guess it's like, right, let's have a digital twin. Okay, where's all the information? Oh, it's in a mess, isn't it? Oh man, how are we going to sort this out? That's going to cost, and there's no magic. There's like, how can we magically run some scripts? Oh, we can't. We need to have people actually unpicking it. And it's that initial cost, which goes to your point, Dave, I guess, of sorting out the information standards early on really pays dividends in the future because of that consistency. That even if you just made the naming convention consistent across all systems.
My next question was actually around information standards, and as you've all touched on it a few times now, I was just wondering, you know, is there a standard that that's recommended, and is that something that we can comment on as part of this conversation that we're having at the moment?
One of the good things about standards is there's so many to choose from, which is really sad. But there are emerging standards that are increasingly useful. One of them is this thing called Cephas, Capital Facilities Information Handover Specification, which is an attempt to try and line up the owner-operators and the EPCs to agree that this is the minimum set of information we're going to give you at the end of the project. There's a lot of issues with it, but it's the best thing we've got, and it's the thing that we really ought to try and hang our hat on. And if it's not good enough, improve upon. And sometimes that means taking stuff out, and sometimes it means putting stuff in.
There's another piece. There's industry standard specifications being developed through task forces across clients, and that looks tremendously powerful because then you cut through all the differences and you're dealing with one set of standards across the whole operating platform of all of the, you know, all of our clients. Very powerful.
Yeah, I think that's true. And generating standards is actually very difficult, detailed, time-consuming work. So I don't know if anyone's ever downloaded a World Wide Web XML schema for something. Like, you can put yourself to sleep very quickly trying to go through one of them. But that's the realities of what folks who write these data interfaces then have to implement. Yeah, I guess sitting down and just working through the nitty-gritty and agreeing really low-level stuff like formats for timestamps on things, date stamping, how are you going to handle time zones, all that stuff. There's a lot of work to do at the low level.
I mean, it is possible to translate from one standard in one system to another standard in another system, so long as there's a kind of one-to-one match. Let's take units of measure, for example. I don't mind if we get things coming in feet and inches and we have to produce it in meters, because there's a known and recognized translation standard for that. However, the more you introduce that sort of translation type approach, the more likely you are to A, make a mistake in the translations, and B, lose something. So and that's a matter of being pragmatic. Sometimes it's say, okay, everyone, we're going to use meters and centimeters and millimeters and not allow anybody to use anything else. But sometimes it is appropriate to say, well, we're not going to finalize that standard right now. We're going to allow some translation. And there's a level of pragmatism to be had in that, and an area where, you know, it's all about change management and bringing about different changes at different paces. And I don't think we're the only industry to have tackled this. The automotive industry does it really well. So does shops. You know, the fact that your barcode, it doesn't matter if you're in Waitrose, Sainsbury's, Tesco's or Asda, they're still the same barcode. How did they achieve that? That's enormously powerful, so that the manufacturers can print a thing on the packet of crisps that every supermarket reads and they know it's unique. That's enormously powerful.
So just, I guess, to close on, can you give us any examples of good ones that you've seen recently?
Well, I'd say in terms of digital twins and using it, I mean, I've seen it used recently in a job in the Gulf of Mexico, and this is around the commissioning phase of a job. So the platform's built, it's about to go through that classic we're talking a lot about, of course, on handover between the EPC contractor and into the client, and the commissioning, and a few challenges during commissioning, and the digital twin there looking into when they've got problems with actually bringing on the oil, being able to close down certain systems, being able to look at the scenario of different bypass lines being used, separator turned off, and be able to do all of that on an operational digital twin before you're actually doing it on the actual physical offshore. That
and what was the interface
transformational. Sorry,
Andrew, what was the interface to that digital twin?
The interface to the digital twin, I mean, that's just come out at the end of the design, so it's reflecting all of the design information and everything, and then essentially it's being used as a tool for the commissioning team. They can look at it offline and look at the best way of intervention in terms of which valves and sequencing and parts they're going to change to actually bring those separators on in the most efficient way. Of course, the old-fashioned approach would be you try the different examples and try and get the best outcome. So that was a tremendous approach. That's the commissioning team using the tool in onshore base rather than having to work it all offshore.
Defence industry, which is the UK carriers, the new carrier that's being commissioned at the moment. The Navy originally said that what they need to do is to be able to model a change to, let's say, the launch catapult on the carrier in the digital twin, in order to quickly and easily replace the parts when the carrier is in use some other side of the world bombing some poor third world country. And they need to be able to go out there with the right bag of bits, know exactly what they've got to do before they get there, do it, and then come back really, really quickly without impacting the operational efficiency of the asset. They built a digital twin right the way from the very start of the project. They didn't do it in any of the recognized tools that you and I know about, but nevertheless, they achieved success in that respect. And I think that's the sort of thing we do. The other one I've got is a car. I don't own a BMW. I don't have a hope of owning a BMW ever, really. But I'm told that if you go into a BMW maintenance garage and say, my BMW is not working, it seems to have you can describe the fault. They'll ask for your vehicle number, and they will type it into their machine, and they will know exactly what parts that BMW has in it. And actually, the other thing they know is its maintenance history, how many miles it's done, etc., etc., etc. So they can easily provide you with a very expensive replacement part.
They've actually evolved that now, so they don't even need to type it. They literally take your key. They take the key and they scan it, and it kicks out all this information.
Are you a BMW owner, Effie?
I have been for many years, not at the moment, but I have been. Sorry.
Murray, can we come and work for you?
And have been fortunate enough to see their technology evolve, which, by the way, blows my mind. And that's one of the reasons why I love their cars so much. It's nothing to do with, well, I love the cars anyway, but it's actually their tech, and it's something I end up in massive conversations with them about, because just how it's evolved over the years, and they're always ahead. So, I was talking to somebody months ago, and they were saying to me, the next versions of the cars are all going to be, you're going to be able to program your destinations in and things like that, and it's going to just know how to get you there. You're not even going to really be in a position where you're going to need to touch it. We're starting to get into that era that we used to watch on films when we were younger. So it fascinates me. But yeah, to your point, it's the key. No more typing. They just scan that key and they'll know exactly parts, age. They'll know all the information, what you'll need. They'll tell you in advance that you're coming up to needing something because they can read it. It's fascinating. But as Murray knows, I'm a bit of an AI buff, so it doesn't surprise me that I know that.
No, and I guess for someone like BMW, where they make lots of the same thing, it makes real sense to completely model it, because you model it once and you build loads of them. With the big industrial assets, there's only one of them, and everyone's different. So there's I guess it's custom each time. And you mentioned the carrier, Dave. That raises an interesting point, that making changes, because what they did then is they made a change on the digital twin that wasn't yet on the physical twin.
Yes.
So you then need a version. So if I'm interacting with the digital twin and I search for something, if the new catapult has been digitally designed, I don't want to see it in my search results, and if it's not there on the ship, possibly I only want to see it when it's been implemented.
That goes to the project memory. So you know what's out there, and what I'm hoping would happen is when the guy goes out to fix the catapult, the last thing he does when he's done up the last bolt is update the digital twin to go from this is something that's under construction to this is something that's built.
So
that
commit.
You get to see the thing that's built. He or she is looking at the to be state for that thing. So you've got to work that. That's kind of all about how you marry up process to the digital twin, as it were. And that's really, really important as well. It's all about how the people using the digital twin work with it and understand how to make changes in a controlled way.
No, it's absolutely fascinating subject. And I think what's most exciting is actually we're very nearly there in many ways. If we just, like what you guys are saying is you're dealing with many of things now. And if you compare them to where we were 10 years ago, we're actually a long way ahead already. And even if we could just join those systems up, we'd have digital twin version 1.5. I don't know.
That's one of the tantalizing things about this. It's so near and yet so far. You know, I think the real challenge is these things are within our grasp, but they're also quite difficult to attain, because what really needs to change is the culture of the industry, not the tools we're buying. We probably have to buy fewer tools and not spend so much on tools. We have to think about how we structure what we're doing.
Hopefully, now that we've come into an era where I think a lot of businesses are pivoting and trying to make better decisions, Murray and I have talked about step-by-step process and agile and all sorts of things over the conversations that we've had. And, you know, we're seeing it in front of us that a lot of companies are adopting that approach. So hopefully as they pivot, you know, with it comes change and acceptance, which be amazing. I do have one question, being the AI buff, and I'm just going to ask this just for really interest, really. Digital twins and AI together, I mean, as an evolution, what are your thoughts on that?
Big question.
Right, so ask them, don't I? And then it goes quiet.
Who's that the question to? Well, let me say, AI, there's two types of AI. But the one that works is narrow AI, where you focus it on a specific problem. So the question with digital twins and AI, well, what will the AI be doing? Because then this comes to the question of the trust in the output of the model. You're like, well, I need to be able to know that the information was complete, so that whatever output, I can know it's at least calculated on a complete set of inputs. But the second is, well, how did you even come to that decision if it's recommending I do something? So I don't think there's scope in the near future for AI doing intelligent stuff based on the whole model. But I do think there's scope for AI making, being an additional pair of eyes on the integrity of the model and helping the humans make sure it's consistent, spot gaps, suggest. And AI could be very good at suggesting relations between things that we've missed, categorizing stuff. So talking about information maturity, there's some stuff where you want to know absolutely I have got every instance. For example, wells. When I search for list the wells, I need to know every production well that I have. I can't be like, well, that's probably the wells that you've got. It's like, no, it's completely auditable. I need to know that. But there's other stuff where it's like, it might start to infer, say, well, this looks like you're taking a decision here based on what you're doing. And you go, oh, yes, it is. Do you want me to add relationships to a new decision object? That's actually helpful. You know, that would save some time. of humans having to physically create stuff. So I definitely think there is a role for AI in helping us maintain the model and even grow or add knowledge to it over time.
Yeah, witty one. AI is easily trumped by human stupidity. I think there is an opportunity for AI to help. I think what you've just said, Murray, is AI to help advise things and suggest things. And at the moment, we shouldn't really be the victim of the computer. We should be the master of it. I think that should be true of all time, in fact. However, I think the computer is increasingly going to be suggesting things to us, and we're going to be increasingly trust what it suggests. One of the things that somebody posted in the LinkedIn conversations we've been having is how are we going to use AI to take a rather ramshackle set of data about an asset and make sense of it? And I think there's some real mileage in that. In other words, retrospectively build a set of information standards from the data that we've got, and also find where the data lacks a decent standard. I think there's some real mileage in that, simply because I've sat in front of a pile of old data from old facilities and thought, how on earth am I going to do this? There's a million records. I don't have a hope. So I then sort of iteratively go through and try to progressively make more and more sense of that data as I go, using simple IT tools like Microsoft Access to sort of try and spot patterns, spot structures, spot missing, spot area outliers, and all that kind of thing. I think I would be very happy if I could teach an AI software to do that for me in a day, whereas before it would take me several months to try and make sense of some existing data. So I think there's real mileage there, but only ever to make it suggest things that I then endorse, rather than
that's important.
Do it for us.
I think what I'm hearing is attended automation. So attended automation is when AI works with the human, with us, and it works together. Unattended automation is when the AI bots take over the whole process. But to do that, there's got to be massive trust in that system. Those processes have got to be, know what it's doing end to end, so the bot can work seamlessly, and then it will grow upon that knowledge. So I think what I'm hearing is that yes, there's room for it, but very much in a attended automation type process.
Agreed.
Working with you.
Yeah.
So yeah, no, it's fascinating. Thank you.
Good.
Andrew, just what are your thoughts on AI?
Yeah, I mean, I'm completely with what's been suggested. You can't let it, it's not to replace, I don't see it just replacing the inputs and thinking and thought process of humans. This checking type function or verification, I can see that it can get the accuracy and help us avoid errors. It might, for example, check through all of the P&IDs and check the sizing criteria. We have had instances where valve sizing has led to issues in operations. It could take the lessons learned and make sure that we have actually implemented it correctly through the P&IDs, the model, and things like that. It could be very valuable in that sort of thing. So I think it's an assisting tool, as Effie was saying. That's how I see it at the moment. Could it be more? I'm sure it could be more, but I think you've got to build on the success as you go, haven't you?
Definitely.
Okay. Wonderful. Honestly, thank you so much. It's so exciting to hear about this topic, and I know I'm such a learner, so I love learning, and it's just been a real pleasure to sit here and listen to you all have this conversation. For anybody who is watching this video at the moment, by all means, please, if you've got any questions, comments, just comment below, no matter what platform you're on. We will see them, we will answer them, yeah, we're always really open to other people's views to carry on this conversation as well. So
that's great. I look forward to seeing it.